Hello students, welcome to today's session. In the last session, we discussed about differentiation in basic mathematics. So next, here we are going to discuss about integration. What is exactly the integration? Generally, some mathematical operations are having their inverses. Like, for example, addition, the inversion is subtraction. For division, the inversion is multiplication, or the multiplication, the inversion is division. Like for integration, the inversion is differentiation. For the differentiation, the inverse function is integration. So let's welcome. Today we discuss about that integration only. So what is exactly the integration? The integration is nothing but we can take a summation or the collection or the summation or else collection. For example, we are guessing that. So, for example, if you are taking a small plant, the growth of the plant, we are estimating it. How we are estimating? For example, in one day, if the plant is growth by 1 millimeter, in one day, how much? The growth is 1 millimeter. In 365 days, how much it is going to grow? In 365 days, how much it is going to grow? So, which is going to grow in 365 days? For example, 365 millimeters. 365 millimeters means actually here we have one day 1 millimeter, but we are estimating it in 365 days the growth is going to 365 millimeters. So here what we are taking from the starting day to next 365 days, before only we are estimated it, the total summation of the all days growth, that is 365. Means it's not compulsory and it is not necessary to be exactly, because that may be one day it is 1 millimeter, but another day it may be more or less. Whatever the total growth, if we are taking the total growth, the summation of the total growths, that's we are taking simply integration, total growth. So generally we are using this symbol integral. This symbol is called integral. How we are using d by dx, differentiation with respect to x, we are saying if you have here, in case if you have integral dx means integration with respect to x, integration of any function with respect to x, we are taking that integral dx. Or d by dx means what we are saying? Differentiation with respect to x. D by dx means differentiation with respect to x, and this integral dx, integration with respect to x. So how we are taking the integration? Very simple here. Integration is completely opposite to the differentiation. So first of all, you just go through the differentiation. So here I am giving a function d by dx of x power n. D by dx of x power n. Generally, what is the differentiation of that? Simply we are writing n into x to the power of n minus 1. N into x to the power of n minus 1. Means what we are doing? What is the value in the power? That value we are taken as multiplied, means quotient, and the power is reduced by 1. N into x to the power of n minus 1. N into x to the power of n minus 1. Whereas comes to the integration, you can take here same integral x power n dx. Integral x power n dx. Here differentiation x power n means n into x to the power of n minus 1. Here integration x power n is what we have to do. Here we are taking the quotient power as the quotient, so multiply. But here opposite means what we have to do? We have to take compulsory division. So here decreasing by 1, so that's why here increasing by 1. Decreasing by 1, here increasing by 1. X power n plus 1 upon n plus 1. x power n plus 1 upon n plus 1. Very simple here. Here what we did? Simply we are taking the power as the quotient or multiply. And here division. Here decreased by 1. Here increased by 1. Means simply what is the integral x power n? Integral x power n is x power n plus 1 upon n plus 1 plus c. C stands for a constant. What is the purpose of this constant? We will discuss. Now just I am going to check is it the equation is correct or not. First of all, I am taking a function, means this function I am considering x power n. So this function I am taking x power n and I am integrating it. X power n plus 1 by n plus 1 we got. Now I am going to differentiate this function, only this function. So then what is the answer? You are getting wondered. X power n plus 1 upon n plus 1. For example, whatever this n plus 1, this is a constant. There is no change by this constant. Now only you can imagine, you can only observe this series look like x power n only, na? X power n means in this form. So just apply that formula. X power n means nothing but n into n value how much? N plus 1 into n into x to the power of n minus 1. N is nothing but here n plus 1 minus 1. And this constant is like this only, n plus 1. Now this n plus 1 will be cancelled. Here plus 1 and minus 1 also cancel. Then how much you got? X power n. How much we consider here? X power n. X power n को क्या किया हमने? पहले इंटीग्रेशन किया था. एक बार इंटीग्रेशन करने के बाद कितना मिला हमको? X power n plus 1 by n plus 1 plus constant. अब इसको डिफरेंशिएट किया था, फिर भी अब कांस्टेंट भी लीजिए. कांस्टेंट डिफरेंशिएशन क्या हो जाएगा? Constant differentiation 0. Constant differentiation 0. So see here, x power n plus 1 upon n plus 1. X power n plus 1 upon n plus 1. So means actually x power n जैसा है. X power n is n into x to the power of n minus 1. Here n का प्लेस में कितना है? n plus 1 है. So x to the power of n plus 1 minus 1 plus 1 minus 1 will be cancelled. So remaining how much you have? X power n. मतलब इसके बाद आपको क्या समझ में आया था? एक फंक्शन को हम एक बार डिफरेंशिएट करके और फिर भी इंटीग्रेशन करें तो आपको सेम वैल्यू मिल जाएगा. मींस एनी फंक्शन इफ यू आर मेकिंग वन टाइम इंटीग्रेशन और वन टाइम डिफरेंशिएशन देन यू आर गेटिंग द सेम फंक्शन. फॉर एनी फंक्शन you are making one time integration and one time differentiation, then you are getting the same function. So once again, see one more example we will take here. For example, here I have integral x square dx. How much? X square dx. What is the integral x square dx? What is the integration of that function? Apply this formula. How much you are getting? X power n plus 1. X power n plus 1 means 2 plus 1 by x power n plus 1, 2 plus 1 plus c. Nothing but how much you are getting? X cube by 3 plus c. X cube by 3 plus c. Integral x square dx. X power 2 plus 1, 3 by x power by 2 plus 3, 3. So 2 plus 1, 3. So now again this function को हम differentiate करो. Immediately make it differentiate. If you are differentiating, x cube by 3 plus c is equal to x cube by 3 plus c is equal to x cube का integration differentiation क्या हो जाएगा? x cube का integration differentiation, sorry not integration, integration already किया था हमने, differentiate करो. x cube का differentiation, x cube 3 into x square. Yes or no? Yes. By 3 constant differentiation 0 cancel. Or how much we got? X square. How much we took here? X square. X square को एक बार इंटीग्रेशन करें तो आपको x cube by 3 मिला है. Means one time if you are making the integration, you got x cube by 3. Then immediately you are making the differentiation, then you got x square, same function. Any function we are making one time differentiation, one time integration, you are getting the same function. Any function you are making one time integration and one time differentiation, again you are getting the same function. In these two examples, first we did integration and then differentiation. We will try some another condition. First we will take differentiation and then we will make integration. For example, here I have a function d by dx of x power 4. d by dx of x power 4. What is the value of x power 4? Means differentiation of x power 4. Yes? Tell me. Yes. 4 into x to the power of 4 minus 1 means nothing but 4x cube is the differentiation of x power 4. Now, इसका इंटीग्रेशन करो, सिर्फ इसका इंटीग्रेशन करो. If you are making the integration, so the integration value is integral 4x cube dx. Integral 4x cube dx means actually same rule here, same rule we are applying. In the differentiation में आपको कभी भी constant के साथ रहे तो means if any function is variable is the constant coefficient, we are not disturbing the constant. We are not disturbing the constant means here we are not going to disturb the constant. So 4 is like that only. Then x cube means x power n जैसा है. x cube का इंटीग्रेशन क्या हो जाएगा? x to the power of 4 3 plus 1 4 by 3 plus 1 4 3 plus 1 upon 3 plus 1. So 4 cancelled plus maybe a constant. So then how much you got? X power 4 only. The differentiation of x power 4. And finally, a one time differentiation and one time integration. How much you got again? X power 4. Means what you understand from here? Any function is making one time differentiation and immediately integration. Then you are getting same function. Or else any function you are making integration and immediately differentiation. Again also you are getting the same function. And we will see some more examples here. So here we are taking here integral x power n dx. What is the formula we are using? N x to the power of n plus 1 upon n plus 1 plus c. C stands for constant. Now we'll take some examples here. What are that examples? See here. Integral x square dx. X square dx means how much you are getting? Simply x cube by 3 plus c. Integral x power 4 dx or x power 5 dx you can take. X power 5 dx. How much you will get? X power 5 means x power 6 by 6 plus c. Because x to the power of n plus 1 by n plus 1. Here how much we have? N is 5. 5 plus 1 6 by 6. Next integral x power 9. Integral x power 9 dx. How much you are getting? Integral x power 9. Yes. X power 9 plus 1 10 by x power 9 plus 1 10 plus c. X power 9 plus 1 by 9 plus 1. So means here very simple here. X power n dx. X power n plus 1 by n plus 1. X square x power n plus 1 means 3 plus 2. Sorry. 2 plus 1 3 by 2 plus 1 3. X power 5. X power 5 plus 1 6 by 5 plus 1 6. X power 9. X power 9 plus 1 10 by 9 plus 1 10. Like that here. In case if we have negative functions, then negative functions means, for example, we have x to the power of 1 by x power n. So means integral 1 by x power n dx. Integral 1 by x power n dx means this is we can able to take integral x power minus n dx. Yes or no? Yes. So simply apply the formula. What we are getting? X to the power of minus n plus 1 by minus n plus 1 plus c, constant function. The integration of 1 by x power n dx is x to the power of minus n plus 1 by minus n plus 1. And we will take some examples here. For example, what I am considering here, simply I am taking the functions integral 1 by x square dx, integral 1 by x square dx. X square, what we can able to write? X to the power of minus 2 na? Yes, x to the power of minus 2 into dx. How much you are getting? X to the power of minus 2 plus 1 by minus 2 plus 1. X to the power of minus 2 plus 1 by minus 2 plus 1. X to minus 2 plus 1 means x to the power of minus 1 by minus 1. Means finally how much you are getting? Minus 1 upon x. Means what is the integration of 1 by x square dx? Minus 1 upon x. And also take one more, integral 1 by x cube dx. Integral 1 by x cube dx. X cube dx means x cube, what we can able to write? 1 by x cube means x to the power of minus 3 into dx. X to the power of minus 3 plus 1 by minus 3 plus 1. Minus 3 minus plus 1 means x to the power of minus 2 by minus 2. So that minus will goes here, then minus 1 by 2x square, minus 1 upon 2x square, minus 1 upon 2x square. So let's see, one more we are taking, no problem, one more we are taking. Can you tell anyone? Yes. What we will take? Integral x power 6 dx, x power 6 dx. X power 6 means how we can take? Simply x to the power of, 1 by x power 6, 1 by x power 6. 1 by x power 6 means x to the power of minus 6 dx. Minus 6 dx means x to the power of minus 6 plus 1 upon minus 6 plus 1 plus constant. Minus 6 plus 1 is minus 5 upon minus 5. Means finally minus 1 by 5 into x to the power of 5. Minus 1 by 5 into x to the power of 5. So that is simply what we are taking, that integration in negative functions. So now what you have to do? You have to practice it for the positive values. N is equal to 1 to n is equal to 9. And also the ratio values n is equal to minus 2 to n is equal to minus 9. Why it's not minus 1? We'll discuss. N is equal to minus 1 to minus 9. And also we are taking some rational numbers also. We'll see here. So we will see some more examples in integration. Let's see here. Integral root x dx. Integral root x dx. Root x means, now what we are discussing, these are all indefinite integrations. So root x means what we can able to write? Integral x to the power of 1 by 2 into dx. X to the power of 1 by 2 means 1 by 2 plus 1 by 1 by 2 plus 1 plus 6. 1 by 2 plus 1 means x to the power of 3 by 2 by 3 by 2. X to the power of 3 by 2. 1 by 2 plus 1 means simply 3 by 2 by 3 by 2 means 3 by 2 means how we can able to write 2 by 3 na? This will goes to 2 by 3 into x to the power of 3 by 2. So this is simply the integration of root x. Integration of root x. And also see some more examples. Integration of x to the power of 3 by 2 dx. X to the power of 3 by 2 dx. How much you can take? X to the power of 3 by 2 plus 1 by 3 by 2 plus 1. 3 by 2 plus 1 by 3 by 2. 3 by 2 plus 1 means how much you are getting? X to the power of 5 by 2 by 5 by 2. So that is simply 2 by 5 into x to the power of 5 by 2. And also you can check integral x to the power of 7 by 2 dx. You can take anything, 7 by 2 dx. 7 by 2 means x to the power of 7 by 2 plus 1 by 7 by 2 plus 1. 7 by 2 plus 1 means how much? 2 plus 7, 9. X to the power of 9 by 2 by 9 by 2. That's we can take 2 by 9 into x to the power of 9 by 2. 2 by 9 into x to the power of 9 by 2. So this is simply x power 7 by 2. X power 3 by 2. So like that functions, whatever if they are giving, that you can easily integrate it. And also you can practice from the values of, and one more thing we will take, x to the power of 1 by root x dx. 1 by root x dx. So what is the value? 1 by root x dx. So let's see. 1 by root x means we can able to write 1 by x to the power of minus 1 by 2. X to the power of 1 by 2 dx. This is also we can able to write integral x to the power of minus 1 by 2 dx. Minus 1 by 2 dx. Minus 1 by 2 means that's look like x power n now. Then apply the formula. X to the power of n. N is minus 1 by 2 plus 1 by minus 1 by 2 plus 1. So the value is goes to simply minus 1 by 2 plus 1 means the value is goes to x to the power of 1 by 2 upon 1 by 2. X to the power of 1 by 2 means the value means this 2 will comes here, this 2 will comes here, 2 into root x. So 1 by integral root x dx means simply 2 root x. 1 by root x dx is 2 root x. So like that you can practice the values of positive functions also and as well as negative functions also. How much time you are practicing, how many examples you are practicing, that much you can get the perfection. So next we will see some more properties here. The first property is integration with constant coefficient. Integration with constant coefficient or integration of a constant function. We will see that. Integration of a constant function. Constant. Integration of constant. Integration of a constant. So here I am taking a function integral some constant into dx. Integral some constant into dx. Generally we know that differentiation of constant function is 0. Then what is the integration of the constant function? Simply. So see here the constant. Constant is we are taking constant only. And then integral. Here 1 is there into dx. 1 is nothing but what we can able to take x to the power of 0. Something power 0 1 na? Yes. Into dx. The something power 0 into dx. Something power 0. C into something power 0 means how much you are taking? X to the power of 0 plus 1 by 0. N plus 1 by n plus 1. Integral n plus 1 by n plus 1. Means how much you get in integral? Simply 1 0 plus 1. 1 only. 0 plus 1. 1. 6. So what is the integration of the any constant function? Is you are getting sum of the value x only. If there is no constant, means for example have only integral dx only, then integral dx only. Integral dx only. Then simply what we have to take? 1 into dx. 1 is integral x power 0 into dx. X power 0 means x power n na, x power n plus 1 by n plus 1 dx. Sorry, x power n plus 1 by n plus 1 is simply x. So what is the value of integral dx is x. Can you say what is the value of integral ds? Means with respect to s if you are taking the integration, then s only. What is the value of integral dt? T only. What is the value of integral dv? We are going to use this all in physics. V only. So whatever the function we are taking, that integration, whenever we have the only, means here nothing is there, the meaning of that constant. So the value is simply we are taking like this. So integral dx is x. Integral ds is s. Integral dt is t. Integral dx is x. ds is s. dt is t. Means here nothing is there. That means you have to imagine 1. 1 means we can able to write something power 0. Something power 0. And that's only we are taking like this. So that is simply integration of a constant. Integration of a constant. Whereas if integration if we are taking with a constant coefficient. Constant coefficient. Integration with constant coefficient. Integration with constant coefficient. Yes. See here, integration with constant coefficient. For example, I have here integral 3x square. Integral 3x square dx, where 3 is a constant function. We are not disturbing the 3, just we are writing 3 of integral x square dx. 3 of integral x square dx. Integral x square is nothing but x cube by 3. Integral x square integration, x to the power of n plus 1 by n plus 1 na. So then simply you are getting x cube plus c is there, but no need to mention always. If we have a constant function ax power 5, a is a constant here, into dx, then what we have to take, a we have to write out of the integration, then x power 5 dx, x power 5 dx. So a into x power 5 means x power 5 plus 1, 6 by 6 plus c plus c. So that's a simply whatever we are getting the constant coefficient, that we have to write out of the integral, and remaining we can make the integration. So that's about the constant coefficient integration and integration of a constant function. Some more examples we will discuss. If the words are with some like this, integral v plus u into dx, means those are separating by the separation. Then how do we can take the integration here? Very simple here. Integral u dx plus integral v dx. U dx and then v dx. So see one example. Here we are taking. There is a function you have integral x square plus 3 into dx. X square plus 3 into dx. So 3 is constant here. So what we have to take? Simply integral x square dx plus integral 3 dx. Integral x square dx plus integral 3 dx. Integral x square integration, x cube by 3 plus 3 is a constant, so that's why we are not disturbing the 3 out of integration, and then here only dx. Integral only dx, not the only dx, integral dx. Integral dx how much? Is x. So then what is the integration of this function? X square plus 3 means x cube by 3 plus 3x. And see, one more example we will take. Integral 3x square or 3x plus x, 3x plus 4 dx. 3x plus 4 dx. So here 3 is the coefficient of x here. So that's why what we have to take, integral 3x dx plus integral 4 dx. 3 is constant, then integral x dx plus 4 is constant, integral dx. Integral x dx means how much you are getting? Simply x square by 2 plus 4 into integral dx means x. 3x square by 2 plus 4x. So like that, many examples you can able to solve, many examples. And one more we'll see here. In case if you have negative operation, then integral u minus v dx. Integral u minus v dx. Integral u minus v means very simple here. Integral u dx minus integral v dx. First term integration minus second term. If it is plus, first term integration plus second term integration. We'll take one small example here. Integral x square minus 2x into dx. What we have to take? Integral x square dx minus integral 2x dx. Integral x square means x cube by 3. Minus is minus only. 2 into integral dx. So the value is x cube by 3 minus 2 into integral x is x square by 2. 2 to cancel. So then how much you are getting? X cube by 3 minus x square. So like that we can take many examples here. Many examples based on this. So just we discuss related to the integration. In integration, what we consider here, integral x power n dx, x power n plus 1 by n plus 1. And also we apply the linear property, means if you have integral u plus v, so that means integration of the u plus v, integral u into dx plus integral v into dx. So now we have some basic formulas here. Let's we'll see some basic formulas what we are using in the integration. So integral x power n dx, what is the value we are taking? X power n plus 1 by n plus 1 plus c. C stands for constant. In case a constant you can take. In case if I am taking integral n into or c into x power n dx, where c stands for a constant function. So we are leaving the constant and remaining we are taking the integration. So the remaining integration is c into x to the power of n plus 1 by n plus 1 plus constant. Here c also a constant function. And integral 1 by x dx. 1 by x dx. If you try to apply the normal basic formula, so we can write x to the power of minus 1 into dx. So that means x to the power of minus 1 plus 1 by minus 1 plus 1 means you are getting how much? Something upon 0, infinity. No, it's not possible. So the value is simply ln of x is nothing but log e x plus constant. The constant is common here. In case if we have integration of the exponential, integral x e power x dx. Integral e power x dx, the value is simply e power x plus constant. E power x plus constant. This constant we are taking in general way, but no use of the constant. Some physical equations we are using this. In case if you have integral e power ax dx, so here you can observe the function is little bit changed. Integral e power ax is integral e power ax is e power ax only, but ax is we have to take a d by dx of ax. We need to take the differentiation of that function also. The differentiation of the function ax, the differentiation is goes to a, so that is e power ax upon a plus constant. Here also plus constant. Integral a power x dx, how much you have? Integral e power ax upon a. And you can take some trigonometric functions. Trigonometric functions are taking one by one. Integral sin x dx. Integral sin theta d theta also you can take, no problem. Integral sin theta d theta. Integral sin theta d theta. Integral sin you are getting cos theta plus constant. Integral sin you are getting cos. In case if we have integral sin x into d theta. Integral sin x into d theta. So integration of sin x is minus cos x upon differentiation of theta is dx by d theta. Dx by d theta. Means in differentiation what we are doing, in case if the function, differentiable function and differentiating function both are different, then what we are taking? We are taking the differentiation of the, for example, it is the differentiation of sine function is cos function into the differentiation of cos function is only we are taking as only d theta by dx or dx by d theta. Or do one thing, you can take it is as x only. This is also x only, and this is x only keep, and this is theta, and this is x. Now it is goes to theta, and this is d theta by dx, because generally dx is going somewhat habitual words, so that's what I'm taking here. So sine, only sine integration is cos. Only sine integration is cos. Sine integration is cos. And again theta integration means again we have to take divided upon d theta by dx. Divided by d theta by dx we have to take. And the second, you can take integral cos x dx. Cos function is a sine plus constant. Integral cos theta into dx. Integral cos theta into dx. Theta is another function. So that means what we have to take? Integral cos integration sine theta by d theta by dx. D theta by dx. Differentiation of theta. Means I will take one more example for you. One more example here. For example, integral sine ax dx. Ax, here ax is a complete term. Sine ax dx. Sine integration cos. How much? Cos ax upon d by d theta of d by dx of ax. Differentiation of ax. How much you are getting? Minus cos ax upon differentiation of ax. A is constant. Only a is a. X, differentiation of x is 1. So then you can get a. Differentiation of integration of sine ax. Integration of sine is cos. And d by dx of ax is a. Next, integration of cos ax dx. Cos integration again sine ax upon d by dx of ax. D by dx of ax. Ax, differentiation of ax is goes to a. Differentiation of ax is goes to a, means so this also same and this is also same. Here theta, instead of theta I am taking ax to avoid the confusion. And some more are there, and that's also we'll discuss. So we'll see some more trigonometric functions. Integral secant square x dx. Integral secant square x dx. Secant, generally in d by dx of tan x is secant, and integration of secant square x we have tan x. Integration of secant square we have tan x. In case you have here integral secant square ax dx. Integral secant square ax dx. Secant square ax, nothing but tan ax plus c. C stands for again constant upon d by dx of ax. D by dx of ax means how much you are getting? Simply tan ax upon d by dx of ax is a. So like that you can able to take. Next, integration of cosecant square x. Cosecant square x dx. Cosecant square x, how much you are getting? Minus cot x plus c. Minus cot x plus c. This is fourth. In the fourth only, integral cosecant square ax dx. Cosecant square ax dx. Cosecant square ax minus cot ax upon d by dx of ax. D by dx of ax means a. So minus cot ax upon a. Minus cot ax upon a. So means sine function cos function, and then secant function, and then cosecant function also we saw that. And these are the some integrations. And next we have the indefinite integrations, these are, and then we will move to definite integrations. So next we have definite integration. What is definite integration? What is indefinite integration? Indefinite means they are not having a particular limits, but in the definite integration we have a particular limits. What is the meaning of the limits? So let's have a look here. So here we have an example. Integral limits a to b. What are the limits? A to b, x power n dx. A to b, limits from where to where? A to b, and x power n dx. So nothing we have to do. First you can take the integration of that. Integration of x power n plus 1 upon n plus 1. And then limits. What are the limits from where to where? A to b. A to b. Means what we have to do? We have to substitute upper limit minus lower limit. Upper limit b to the power of, means 1 by n minus 1, n plus 1 you can make common. Then in place of x you have to put b to the power of n plus 1 minus a to the power of n plus 1. This is the right process. If we are doing like this, b minus a whole to the power of n plus 1, this is wrong. What you have to do? Upper limit minus lower limit. Not like this, b minus a whole to the power of n plus 1. So both are not equal. There is a huge difference between them. So that we have to do that. Simply limit application. Limit definite means there is a particular limits. There is a particular limit. Generally we are using a particular limit. That is a definite. So in physics what we are taking? In physics what we are taking? In a particular time from 0 to 5 seconds. Or 0 to 2 seconds, 0 to 3 seconds, like that. There is a particular limit we can able to mention, and that's only we are taken as here definite integration. So let's see some more examples we will do. For example, here I am giving integral x square dx from where to where? Limits are 0 to 2. Integral x square dx. Limits are 0 to 2. That is equal to integral x square. Integral x square how much? X cube by 3. Limits 0 to 2. Means how do we have to apply? Upper limit minus lower limit. Upper limit 1 by 3 you can write common as, no problem. Upper limit how much? 2 cube minus 0 cube. 2 cube is 8 by 3. So what is the integral 0 to 2 x square dx? What is the value? 8 by 3. Integral 0 to 2, integral 0 to 2 x square dx. What is the value? Simply 8 by 3. 8 by 3. Next, we'll use one more. Take here integral x power 6 dx, but integral from where to where? From 1 to 2. Integral 1 to 2, x power 6 means that's going in x cube, you can take x cube dx. Integral x cube dx, 1 to integral 1 to 2 x cube dx. First you can take the integration of the x cube. Integration of x cube how much? X power 4 upon 4. Limits 1 to 2. So 1 by 4 you can write out of the limit, and then 2 power 4 minus 2 power 1. Upper limit minus 2 power 4 minus 1 power 4. 1 power 4. So then 1 by 4. 2 power 4 means 16 minus 1, 15. So that means 15 by 4. What are the limits? X cube dx. From where to where? 1 to 2. X cube dx. Upper limit minus lower limit. So wherever upper limit, x place you have to put t power 4. 2 power 4. Here 1 power 4. So like that we are writing. And let's see some more we will discuss. For example, The displacement means time t square plus 2 into dt, limits 0 to 1, t square plus 2, limits 0 to 1. So what we are taking generally, integral t square dt 0 to 1 plus integral 0 to 1 to dt, right now? Integral t square means t cube by 3, limits 0 to 1 plus 2 into integral 0 to 1 dt, 0 to 1 dt. Here you put the limits, how much you are getting. Let's see how much you are getting here. Upper limit 1 cube minus 0 cube by 3 plus 2 into t value 0 to 1. So 1 by 3 plus 2, that is, means here how much limits you can substitute, even 1 minus 0, upper limit 1 minus lower limit 0. So then 1 by 3 plus 2, 3 2s are 6, 6 plus 1 7, 7 by 3, integral t square plus 2 into dt, how much we are getting? This much. And also, for example, we'll try one more thing, integral sin theta d theta, angle is from 0 to pi by 2, 0 to pi by 2, pi by 2 means 90 na? 0 to pi by 2, pi by 2 means 90. See what is the value happen? Sine integration, you know that, minus cos, angle from where to where? 0 to pi by 2. Take minus common, upper limit cos pi by 2, minus cos 0. So you need to know the values also here. Cos pi by 2, cos 90, 0, minus cos 0, 1. So minus half minus plus. So how much you got? 1. So integral 0 to pi by 2 sin theta d theta, how much you have? Simply 1. So like that, whatever we are taking, there is a particular limit, that limit only we are mentioned as definite integrations. Okay, let's see some more, we have examples. So then how do we are solving? Have a look over it. First one is integral 0 to 3 ax square plus bx plus c into dx. So you can write integral ax square 0 to 3 plus integral bx 0 to 3 integral c dx, dx actually here, plus 0 to 3. First I am writing the separation of this. A is constant, integral x square, x cube by 3, limits 0 to 3, plus b is constant, integral x, x square by 2, 0 to 3, plus c is constant, integral dx is x, 0 to 3. So see here, a into, means a by 3 you can write, means this we can able to write upper limit 3 cube minus 0 cube, no need to mention 0, plus beta and b into 3 square by 2 minus 0, plus c into 3 minus 0. Next simplify here. So what I am doing here, once again see here what I did here. Simply upper limit 3 cube minus lower limit 0 cube, 0 by 3 as usual. Here x square 3 square minus 0 by 2. Here 3 minus 0. That's all. So now a into, this is a 3 cube by 3, 27 by 3 means this value comes to us 9, plus b into 9 by 2 plus 3c. So simply how much you are getting? 9 9a plus 9 by 2b plus 3c. This is the integration of integral 0 to 3 ax square plus bx plus c of dx. How much? 9a plus 9 by 2b plus 3c. And we will move to the next one more problem is here. That is, yes, integral minus pi by 2 plus pi by 2. Minus pi by 2 plus pi by 2 cos theta d theta. Minus pi by 2 plus pi by 2 cos theta d theta. Cos integration, we know that. How much? Sine. Limits minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. So cosine pi by 2 minus of sine of minus pi by 2. Sine of minus pi by 2. So the value comes to you here. Sine pi by 2 is sine pi by 2. We know that 1 minus of sine of minus theta minus sine theta. Minus of minus plus. The value also 1. So the total value is 2. Here the integral minus pi by 2 plus pi by 2 cos theta d theta value is 2. Next we have third problem. What is the third problem? Integral u to v mv dv. It is the physics completely. Means mv momentum and u to v initial velocity to final velocity. How much? Take the integration. M is constant mass and integral v dv. U to v. Integral v dv. V integration v square by 2. So then the value is m into v square by 2 from u to v. So then m into v square minus u square upon 2. What is the integration of integral u to v mv dv is m into v square minus u square by 2. Last but not least, fourth one. What is that? Integral f dx. Without limit they are giving. Integral f dx. But we take the limits. What is happening? Taking 0 to 1. No problem. 0 to 1. F value given as gmm upon x square dx. So it's look like which formula? Which force? Gravitational force. Gravitational force. From where to where? Simply they mention 0 to 1. G, gravitational constant, constant only. Mass of the earth, constant. Mass of the body also constant. 0 to 1. 1 by x square dx. 1 by x square dx. What is the value of 1 by x square? Know that gmm 1 by x square means we can able to write x to the power of minus 2 na? X to the power of minus 2 plus 1 by minus 2 plus 1. I am not having much space there. Minus 2 plus 1 by minus 2 plus 1 means how much you are getting? Minus 1 upon x. 0 to 1. So now how much you are getting? gmm upon minus 1 by 1 is minus 1. Minus 1 by 0. So that is going to infinity. So this value simply what we can take here, minus gmm. Minus gmm. The force we can take like that. So up to now we discussed integration. Then how to we are using this integration to the physics and differentiation also. Both how we are using. Let's see here. So generally we have velocity function v is equal to ds by dt, instantaneous. In case you require displacement from this, so what we have to do simply ds is equal to v into dt. ds is equal to means you are sending the dt there, and then simply you have to take integration on both sides. IOBS means integration on both sides. If you are taking the integration, that is comes to integral ds is equal to integral v dt. Integral ds is yes is equal to integral v dt. If you are taking the limits from u to v, or else v value you can put as at. So whatever you are doing, then you are getting the further expression. So this is a equation 1 you can take. For example, if you know, and this is keep equation 1. Next, in case you know that a is equal to dv by dt. A is equal to dv by dt. That is also we can able to take. Then dv is equal to a dt. dv is equal to a dt. So then integral, if we are taking integration on both sides, then what we are getting? Integral dv equal to integral a into dt. Then v is equal to integral a dt. So what we are doing here, to displacement we are taking integral v dt. For velocity, integral a dt. And if you require velocity, then what we are doing? Velocity is nothing but we are taking the differentiation ds by dt. And acceleration, a is equal to we are taking dv by dt, or else a is equal to also we are writing v into ds upon dv upon ds. v into dv upon ds. By using of these expressions, we also able to take the equations of motion by using of this. This is the total integration topic.